Hi everyone, today our group M want to share with you our thesis review about forecasting Malaysia bulk lactate prices using autoregressive integrated moving average, which is ARIMA, and exponential smoothing done by Mong Chung Fu. So introduction. So natural rubber is an important agricultural product. It can be used to create various items, including tires and latex gloves. So, due to the high uncertainty of natural rubber prices, accurate statistical methods could be used to forecast future natural rubber prices. High accuracy of price forecasts is essential to make strategic decisions since there was a significant time gap between the investment decision and the actual supply of the commodity in the market. So the prediction will aid decision makers in the natural rubber industry buy or sell their raw material at the best.
Moving on, we have our research problem statement. So the volatility and instability of natural bulk latex prices, it is affected by numerous influencing factors such as climate, supply and demand of natural rubber, crude oil prices, exchange rate of foreign currencies. Next, Manchonfu also identified another research problem, which is unstable climate change affects the yield of natural rubber in Malaysia. This caused a fluctuation in natural rubber prices, particularly during the monsoon season. Next, we have several studies in forecasting natural rubber prices, such as ARIMA method, exponential smoothing method, ANN method. Such methods could be the best method for natural rubber prices since the historical prices behave non-linearly. It means that we have to choose among these methods which method is the best.
Okay. The objectives of this research, the first one is to model the historical data of the monthly bulk lactate prices in Malaysia using the ARIMA exponential smoothing and method. The second one is to compare the performance of the forecasting models by using the MAPE and RNFE, which will be discussed in the methodology part.
In the next slide, we have scope of study and significance of study. So this study's scope is focusing on forecasting bulk latex prices in Malaysia, and the historical data are from January 2010 to December 2020 in Malaysia, which retrieved from Malaysian Rubber Board. So for ARIMA model, exponential smoothing and ANN methods, all these three methods are used in this study, and the tool they use is R programming and Minitab. So for the significance of study, this study is actually important to contribute to the knowledge of the forecasting methods on bulk latex prices in Malaysia. And this study also can provide information to the rubber industry and the government sectors. So, so they can be effective at marketing and purchasing, and they develop a strategy to do so in the future.
Okay, this is our review on Mong Chong Fu introduction. So the research is focused on the Malaysian rubber industry and technique to predict the bulk latex prices. So technique used is the what Kaizen said just now, ARIMA exponential smoothing and methods. So his problem statement is able to identify specific problem to solve, and the objectives are clear and practical. This research is necessary to predict and forecast price trend of latex prices, since rubber industries play the significant role in Malaysian economy. Okay, now we move to the literature review.
So for the literature review, we have time series analysis. It is an analysis of time series in a mathematical method concerned with evidence from time series and trend analysis. It is used to forecast historical data to predict the future value and to determine potential change in data. It can be used with machine learning and neural network, and one of its application is artificial intelligence in the field of predictive analysis. In this study, exponential smoothing and autoregressive integrated moving average, and the artificial neural network ANN under the machine learning algorithm is used to forecast the bulk latex prices in Malaysia.
Okay, the second one is exponential smoothing. So it is a univariate time series forecasting technique. So it can be applied to predict data with a symmetric pattern or seasonal component. So there are three main types of forecasting models with unique properties, which is simple exponential smoothing, hot exponential smoothing, and hot winters exponential smoothing, which their characteristic is writing in the.
So for the next slide, I'm going to introduce to you about Box-Jenkins methods. This is a method developed by George Box and William Jenkins in 1976. There's a various type of forecasting model in Box-Jenkins methodology, such as autoregressive integrated moving average, also known as ARIMA, and seasonal autoregressive integrated moving average, also known as SARIMA. And last but not least, autoregressive moving average with exogenous variables, also known as REMAX.
So next, artificial neural network, or also known as ANN. So it is known as one of the algorithms from the machine learning. So a nonlinear mathematical model that reveals a complex nature between inputs and outputs of data to explore new patterns. So the NNN attempt in this way is to recognize the regularities and variation of input data. So the networks are allowed to adjust the hidden layers of neurons if the results do not meet the expected outcome.
Moving on to the next slide, we have literature review of influencer factors of natural rubber prices by Vijayakumar and other researchers. Next, we have forecasting in natural rubber prices from Zahari and other researchers. And finally, we have seasonality of natural rubber prices, research by Sakan and others.
So here are our review of Mong Chong Fu literature review. So his reference includes in the research are very sufficient to support the validity of data use and the forecasting methods used. So the references are all up to date, which are published within 10 years from this research start. And the literature review provides us multiple forecasting methods developed by previous research, so this thesis can determine the most feasible and practical method to use.
A very good day to Professor Muhammad Hisham and my fellow friends. My name is Gong Zijing, and today I would like to present the thesis review on the methodology part. Firstly, I would like to present on the data collection. So 132 data of the monthly bulk latex prices from January 2010 to December 2020 were collected from the Malaysian Rubber Board. And then the data set was divided into two parts. The first part is the prices from January 2010 to December 2019. And the second part is the latex prices from January 2020 to December 2020. So the first part of the data from January 2010 to December 2019 were used to train the model, which includes ARIMA, exponential smoothing, and also ANN. And the second part of the data in 2020 were used to measure the model's performance using MAPE and RMSE. And next, I'm going to present on the first method, which is the exponential smoothing. So if the data is presented without any trends or seasonal component, then the simple exponential smoothing is applied, where the formula is given by YT plus 1 equals to alpha YT plus 1 minus alpha YT. If the data is presented with some trend, then the Holt's exponential smoothing is applied, given by YT plus H equals to LT plus HBT, where LT is the level component and BT is called the trend component. And to calculate the value of LT and BT, we will use this formula. And next, if the data is presented with trend and seasonality, then the Holt-Winters exponential smoothing is applied. And for this method, there are two types, which is the additive seasonality and also multiplicative seasonality. So for the additive seasonality, the formula is given by YT plus H equals to LT plus HBT plus ST plus H minus M. So LT is the level component, BT is the trend component, and ST plus H minus M is the seasonal component. And to calculate the value of this component, the formula is given by here. And for the multiplicative seasonality, the formula is YT plus H equals to LT plus HBT multiplied with ST plus H minus M. So the formula to calculate LT, BT, and ST is given here. And next, for the Holt-Winters exponential smoothing, we also need to calculate the values of the level L0 and trend B0. The values for L0 and B0 is the same for both the additive and multiplicative, which is given by L0 equals to 1 over M bracket Y1 plus Y2 plus dot dot plus Ym, and B0 equals to 1 over M Ym plus 1 minus Y1 over M plus dot 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 until Ym plus M minus Ym over M. And the initial values of the level S0 for the additive one is S0 equals to Ym minus L0, and then dot 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 until S negative M plus 1 equals to Y1 minus L0. And for the multiplicative one, it is similar to the additive one, but just change this sign to the division sign. So X0 equals to Ym over L0 and dot 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 until S minus M plus 1 equals to Y1 over L0. So overall, to conclude on the exponential smoothing, this method is suitable to forecast univariate time series data. So this method is suitable in this research because the data we collect in this research is the monthly bug lattice prices. And secondly, this method is a powerful method as it can be extended to forecast data with consistent trend and seasonality. And next, I'm going to present on the second method, which is the artificial neural network, which is also known as ANN. So this figure shows the architecture for the bug lattice price forecasting, where the first layer is called the input layer to input the data, and the second layer is the hidden layer to process the data, and lastly, the third layer, the output layer, to produce the result. So the first stage is the data pre-processing stage. As the logistic function has the range between 0 to 1, thus the input variables need to be standardized. So to perform the standardization, the min-max normalization was used, given by YT equals to XT minus XMin over XMax minus XMin. And then next, after the forecast value was obtained using ANN, then denormalization was performed to obtain the original forecast value. So this formula is rearranged to obtain XT equals to XMax minus XMin multiplied by YT and then plus XMin. And next, for the second stage, is to build the network of ANN. So firstly, the number of hidden nodes Q must be less or equals to 2P, where P is the number of input nodes. And secondly, to determine the optimal number of the number of neurons in the input and hidden layer, the mean square error should be minimized, which is given by 1 over n YT minus YT cap square. So after the mean square error was calculated, then the network architecture with the minimum MSE value will be chosen to forecast the data. And the third stage, which is the last stage, is the training network and forecasting stage. So in this stage, the multi-layer perceptron was employed to train the monthly bug lattice price and to forecast the monthly prices in 2020. So the artificial neurons are the primary components of an MLP. These neurons, which are positioned in layers of the network, are connected by synaptic weights given by UK equals to summation of J equals to 1 to M WKJ XJ. And next, the strength of connection of the two neurons was given as YK equals to psi bracket UK plus BK. And I think that's all from my part. Thank you, and I will let my teammate to continue the presentation.
My name is Ying. I would like to talk about box-Jerkins method. There are 4 main stages in employing the ARIMA. So the first stage is identification, second stage is estimation, for the third is diagnostic, fourth is forecast. The background of box-Jerkins method is the box-Jerkins method were employed by George Box and Jerkin in 1976. The box-Jerkins model is the mathematical model designed to forecast data range based on input from a specific time series, and it is used to forecast data using a 3 principles, which is autoregression, differencing, and moving average. These 3 principles is known as P, D, and Q respectively. The ARIMA model can be understood by outline shown as here. For the AR stand for autoregression, it refers to a model that shows a changing variable that regress on its own leg, period, and value. For I stand for integrate, it represents the differencing of raw observations to allow for time series to become stationary. For example, data value are replaced by the difference between the data value and the previous value. For the MA, it stands for moving average. It incorporates the dependency between an observation and residual error from a moving average model applied to log observations. For data pre-processing stage, the data normalization such as box call powder transformation is used to convert the non-normal data to stabilize the variance for obeying the normality. The transformation parameter lambda is selected automatically by the Joro method, which minimizes the coefficient of variation for a subspirit of data. This transform can be defined as y sub t equal to log y sub t, where lambda equal to 0, and when lambda is not equal to 0, it is yt minus 1 over lambda. So the time series must be stationary in order to use the ARIMA model. The time series is stationary when the mean variance and autocovariance does not vary over time. The ADF test can be used to determine if the time series is stationary. For the null hypothesis, H0 denote that the time series is not stationary, and the common use is t statistic, shown as here, the t equal to y cap over SE y cap, where y cap is the unit root and SE cap is the square error of the unit root. So the H0 can be rejected if p-value is less than alpha significant level to conclude there is no unit root and the time series is stationary, as y sub t prime equal to y sub t minus y sub t minus 1. For the ARIMA model identification and selection, the autocorrelation function ACF and autocorrelation function EACF plot are also used to determine the order of ARIMA. The property of ACF and PACF for ARIMA is shown in the table below. So here is the formula for ACF and PACF. The Akaike information criterion is known as AIC, can be used to assess the best model selection for the box-Jerkin model. AIC is an estimator of outsample prediction error for the database. As a result, a good model with the least prediction error should comprise the least value of AIC. The formula of AIC and correlated AIC are given as here. AIC equal to n ln SSE plus 2k, AIC sub c equal to AIC plus 2 bracket k plus 1 close bracket k plus 2 close bracket over n minus k minus 1, where the k is the parameter, n is the sample size, SSE is the sum square of the error. Now we move to ARIMA diagnostic checking. In diagnostic checking, residual analysis is used to ensure the adequacy of the model. The adequate model should be comprised residual with property of zero mean, constant variance, non-autocorrelate, independence, and normality. ACF plot can be used as control chart to verify and test the independence of residual in the forecast model. The ACF at lab K and the 95% confidence level with n sample size is computed as CI equal to plus minus 1.96 over square root n. So now is the box-Jerkin method flowchart. At first, we are plotting the time series to obtain the ACF and PACF. To determine the series, is it a stationary? So if the series is not stationary, then we need to apply difference sensing and repeat at step 2 to obtain a suitable ACF and PACF again until the series is stationary, and then we can move on to model selection. After model selection, we have to estimate an appropriate parameter, and then we need to test is it the parameter is significant and the residual is autocorrelated. So if the parameter that we are estimate is not significant and residual uncorrelated, then we move back to the step model selection again until the parameter is significant and residual correlated. And then since everything is alright, then we can move to the step of forecasting. In overall, the ARIMA step is very appropriate for this thesis because we are using a specific time series to forecast the bulk price in Malaysia, especially when it comes to a time series that less than 18 months, there is more appropriate. And now is the forecasting performance evaluation. So the mean absolute percent error, MAPE, is equal to 1 over n, summation of t equal to 1 to n, absolute YT minus YT cap over YT times 100, and the root mean square error is RMSE. The formula is square root 1 over n summation from t equal to 1 to n, bracket y sub t minus y sub t tab close bracket square. And when the lower the value of the MAPE and RMSE, the higher the accuracy of the forecast. The methodology, we think that is appropriate for this thesis. That's all from us. Thank you.
Start. Okay. Hello everyone, I'm Desmond Ching. Today I would like to present about the result and the discussion. First is the time series analysis. In the time series analysis, there has the SCF plot and the FDA test were used to show the stationarity and the seasonality of the time series of the bar latest price. There is no stationarity in the time series since the latest price has the unpredicted tendency over the time and there does not floated around the mean in the time series plot. And then the slower dilation of the SCF in the SCF plot and the p-value which is less than the 0.05 in the ADF test also made the time series not stationary. However, following the first differencing order process, there are the flotation around the mean. They have the significant piece and the delay to the zero at the faster rate in the string SCA plot will make the time series become stationary. And so finally, there is no seasonality in the time series since there is no oscillation and the significant piece in the string SCA plot. And next is the exponential smoothing. In this exponential smoothing, they'll have the initial state and the optimized smoothing parameter were used to express the equation of the whole models. And this initial state and the smoothing parameters will show that the prediction of the bar latest pricing to show that they have the declining trend based on the whole model. And in 2020, the actual data will fall within 95% of the forecast confidence range. Therefore, the prediction is show that the predictable because the test will fail within the predicted range within the probability of 0.95. And next is the bot checking method. And in this bot checking method, they have the tendency model with the p equal to 1 and the q equal to 1 was used because if the AICC value is lower compared to the tendency model with the p equal to the 5 and the q equal to the 5. And almost the tentative model with the p equal to the 1 and the q equal to the 1. The ARIMA 110 was chosen as because is the AICC values is the least, that is negative 900 and 0 f and 0.8 f. And the residue plot of this ARIMA will conclude that the residues are scattered randomly with the mean equal to the 0. That implies that the residue has the constant variance. And then the SCA plot of this ARIMA also show that the residue are independent since they are almost the sample are inside the confidence interval of 95%. And the Aljun box test will indicate that there is no autocorrelation in the residue since the p-value of the Aljun plots are higher than the 0.05 for the old lab. And then the Edison-Darling test and the normal quantity plot also employers to evaluate the normality of the residue, and both conclude that the residue were normal distributed. And based on all the four tests, ARIMA 110 has achieved the criteria to be used as the model of forecasting. And this shows that the graph of the forecasting from the ARIMA 110. Next, I will pass to the Loy Bi Yan.
Greetings everyone, my name is Loy Bi Yan. So I will continue with the artificial neural network ANN. So this ANN model was used to train the data by a backpropagation training algorithm, and the min-max normalization equation was used to calculate the normalization for each raw input and output data set to multi-layer perceptron MPL. The equation is xt is equal to 712 YT plus 347.53. So by utilizing min-max normalization on the standardized time series, the values of the input data are clearly in the range from 0 to 1. There are 4 inputs nodes and the hidden nodes are double of the number of input nodes, which are 2, 4, 6, and 8. The ANN network design, notably MLP, are created with varied number of input nodes and hidden layer nodes using the monetary tools. After the trial of 250,000 and 500 and 1,000 training repetition, the ANN model 481 was chosen since this model has the least mean square error MSE. So the ANN model 481 performed the best in ANN model after first order differentiation. So this is the forecast graph for MLP 481. And I will continue with the forecasting performance evaluation for all these 3 methods. So the accuracy of forecasting was determined by using mean absolute percentage error MAPE and root mean square error RMSE. The lower the MAPE and RMSE, the more accurate the forecasting. And then also the MAPE of less than 10% also implies good accuracy of forecasting. So among these 3, ARIMA, exponential smoothing, and ANN, ARIMA 110 is the best forecasting model. However, since ARIMA is a univariate model, so this model do not consider any other practical factors such as optimism about COVID-19 vaccine, strong economic development, and demand for natural rubber in China, and so on. So by all these unexpected factors, the ARIMA model is hard to achieve a high accuracy forecasting result. Lastly, I will do a review of result and discussion. All these 3 methods were analyzed using the data collected before, so it is difficult to forecast, especially for costs which have too many factors could affect the trend. The natural disaster and pandemic disease are the factors which affect the result of forecasting. These factors are deniable and difficult to predict nowadays. That's all from us. Thank you.
Alright, to summarize, we have our conclusion and recommendations. So as a result, the research have found that ARIMA is the most appropriate model in forecasting bulk latex prices with nonlinear behaviors in this study. The hybrid model is a combination of 2 methods used to overcome the drawbacks of individual techniques and improve the results. Also, several influencer factors should be considered in forecasting the pricing of raw materials, which are supply and demand of raw material, weather conditions, foreign exchange currency, production, and consumption of the raw materials. That's all from our group. Thank you.
Thank you.